All right, this is homework 2. I'll do a few of these questions. We got what, like 10 of them? I don't know. I'll do a couple each video. So these questions are just straight up derivative questions, right? So we want to just be able to take derivatives using product, chain, quotient, all of these rules. So first off, if we were taking this derivative, right? So 3x to the fifth, we're just going to apply the power rule, right? So our power is going to come down. So 5 times 3 is 15. Then we're going to take 1 away from the exponent, so that's to the fourth, plus 2, the derivative of sine. That's just positive cosine. So that's going to be that. For the cotangent, right? So cotangent has a negative derivative. The derivative of cotangent is negative cosecant squared of x. For cotangents, just in case, if you know the derivative of the tangent is secant squared, then if you flip this to a cotangent, this flips to a cosecant, right? So you get your cosecant squared. And then, so I knew that a lot of students will probably do this by bringing the, x to the third up and writing it as x to the negative third, which is fine. We could also think of this as negative 1/4 times 1 over x cubed, right? So if you're taking the derivative of 1 over x cubed, we'd have that negative 1/4. This 3 kind of comes up as a negative, so we get negative 3, and then we just add 1 to the denominator, right? So this term here would be positive 3 4x to the fourth, right? So we get 15x to the fourth plus 2 cosine of x minus cosecant squared of x plus that thing over there. Again, if you felt like doing this as x raised to the negative third is negative 3x, x to the negative fourth, that's fine. All right, so we get negative 3 and then x to the fourth in denominator. Notice again, what we're doing is this little exponent 3 comes up as a negative, and then we just add 1 to the denominator. I don't know why I did this for addition. That doesn't really mean addition. I don't know what the hell I'm doing. So question 2. Again, we're going to take some derivatives. All right, so the derivative of the cosh f prime, derivative of the cosh is just like the cos, right? So we're going to get a sine with an h, a sinh. So technically, we have to do a chain rule up here. This is like e to the u, where u is 5x. The derivative of e to the u is just u prime, e to the u. So we're going to get plus the derivative of the exponent is 5. And then the nice thing with exponentials, they always just stay, right? So we have 5 times e to the 5x. Oh no, we have x to the natural log of x. So we're multiplying these two values together. So that's going to be a product rule. So product rule has 4 parts connected by addition. So we always know the first part, it's the first term. We always know the third term, it's the third part, it's the second term. And then we just take derivatives, right? So this would be the derivative of the natural log of x, which is 1 over x. This would be the derivative of x, which is just 1, right? So I can clean this up. I would get the sinh of x plus 5e to the 5x. X times 1 over x is just plus 1. Natural log times 1 is just the natural log. And this 88 just goes off towards 0. So here's our derivative. I'll do one more in this video. If I look at this thing, well, we got a quotient rule. So I would take g prime of x. Quotient rule has 5 terms connected by subtraction in the top. Our denominator is squared, so we just keep the denominator as is and square it. This first term is just the denominator. This third term is going to be the natural log of x cubed plus 2x. And then it's time to take derivatives of the other stuff, right? So the derivative of the natural log is going to go, or derivative of like this whole term at the top is going to go there. The derivative of 5x minus 1 is going to go there. I'll do the easy one first. Derivative of 5x minus 1 is just 5. All right, so the derivative of the natural log of x cubed plus 2x, we would use a chain rule. Remember, the derivative of the natural log of some function is just u prime over u. So we take what's ever in the natural log, this argument right here, and just drop it down to the bottom, x cubed plus 2x. And then we take the derivative of whatever was inside. So the derivative of x cubed plus 2x, 3x squared plus 2. Should we simplify that? Nah, we shouldn't simplify that. Why would we simplify it? There's nothing really nice that we can do. One really common mistake I think students would make is just canceling like those. Can't do that because we don't have a 5x minus 1 in that term. So don't make that rookie mistake. We've all made it. Let's just not make it anymore, just in case you're still making it.